The first lecture that we will learn today is Introduction to Object Technology. Firstly, we go to the first part, that is programming paradigm. So, in fact, there are some more programming paradigms. I will just introduce you just three main paradigms from the machine code, procedure programming languages, and object-oriented technology. For the machine code you are learning, so you know that it's like very close to the machine code of CPU, right? And it's a sequence programming language. Sequence, that means it will like sequential statement, and you don't have any control statement like branching or loop, right? So the logic is very difficult to follow. Like you do this, and you check the status of some maybe memory space or registers, and you can go back to some previous statement, and your code like spaghetti. It's very difficult to follow, to remember, to write, and the code is very close to the machine code. So you need to understand about the architecture, the computer architecture of the computer's architecture. And if you write the code for this architecture, and you cannot use that code for another architecture, right? And because the flow is very difficult to follow, so it's very hard to fix or maintain the source code. However, the machine code, because it's very close to the assembly is very close to the machine code of the CPU, the developer will have more powerful to interact with the hardware. That is the feature that higher level language, programming language cannot do. So everything has two sides, right? So it's not easy to remember, to write, to fix bug, to maintain. But with the assembly code, you can do many things with the hardware. So that is the power of the assembly code. So that's why assembly code or machine code normally will use for embedded system. Okay. The next paradigm, procedural language, mainly writing the software or program based on the function. You see here. The function, you need to write the function. You see, you learn C already, and you say that everything you do with the function and the data structure. The data follow data structure. So that's why you have the cost data structure and algorithm, right? The data structure is in the data, and the algorithm is in the functions. And the functions and data are kept separately. What about the object programming? Object programming is the main idea of object programming is very different from procedural language, because procedural language, the data and the function are separately. However, in object-oriented programming, the data and function are kept together and make an object. That is an object. Okay, and the object is the object represents the object also in the real world. So it's very close to the real world. You can model the real life object to the software object. So what is object? What is the object technology? We will move to the next part to see deeply, to go deeply on object-oriented programming. Okay. So object technology is not only the programming language, because normally you will do with the programming language. However, that is like very, very basic one and just very small part in any technology. Technology is not only including the language, but also other things like the rules, the principles that you will learn in this course, the theory, the concept, okay? the instruction, all of that you will learn in this course, the instruction, and even database and other tools to support the rules or the principle. Okay. The key here is the principle. That is what I want to say to you. That is very general for many object-oriented programming language. And the language or something like Java or Python is only just one case, and it must follow the principle, the rules, the techniques of object-oriented technology. Okay. So what we learn here is not only language. I just want to emphasize that the rule is more important, because the rules or the principle will be like the general things, and the language is just the concrete thing following the rules. Okay, so you must understand and understand and can practice following the rules. And object-oriented programming, specific or object technology in more general, it's have many strengths, many advantages in the over other paradigms. Like it's already say, reflect the real world. That's it model the real world objects, bring to the software object, so it's close to the real world. And code reuse, architecture reuse. With object technology, there is a set of rules that you can have the code reuse very, very effectively, and stable and easy to change. So if you have some new requirement or changing in requirement, with object technology, very easy to change. Compared to the machine code, it's not easy to change the requirement, or when you fix some bugs or maintain, it's not easy. But for procedural language, it's easier. And with object-oriented programming, it's much easier. And you know that the most complex and large-scale software use the object technology to develop some major milestones. You see here, Java appeared in 1921, and UML2, that is the version that we use today, 2004, before C++, and some Smalltalk is something like the language that Java originated from. Python, Python also appeared the same with Java. And object technology can be used in many types of applications, like client server, web development, or maybe distributed system also, and real-time system, also some embedded system. The object is the key of object-oriented programming. You will model from the real-life object to the software object. You retain the attribute, the properties of the objects, and the relationship between objects from the real life to the software. So that's why we say object-oriented programming is very close to the real world, because we model from the real life to the software. So if you have an object house in the real life, you may have, after modeling, you may have an object house in the software. And the object in the software is an entity with a well-defined boundary and identity that have state and behavior. Okay, the state is the attribute and the relationship with other objects, and the behavior is the operation, the method, or the way that objects interact to each other. So an object has two things, state and behavior. Okay, so I can give an example here. For example, in the real life, we have an account with the account name, balance, and you have some business like deposit, debit, balance inquiry, or some other business, right? And when you model to the software space, you also can have the account object. And you see that this account object has the attribute that is duping, and the balance, yeah, that's the same attribute. And the account object also have some operation that reflect the business in the real world: deposit, withdraw, check balance, etc. Okay, so the attribute here is that is the data. You see the data, and the operation, that is the function. And the function of the operation is only manipulate with the data of that object. That is very different from this. And okay, so you see we have an object, and that is data, and that is a function. Okay, and the function will manipulate to the data. For example, if I want to withdraw money, that is an operation of the object, right? And this action or this operation will when I withdraw money, I will decrease an amount for the balance. So this operation will manipulate with the data balance to increase or to decrease the balance to an amount, right? So the function will manipulate to the data of that object. And other objects will interact to the account object through sending messages. For example, the user object want to check balance, will send a message, check balance, to the account object. So that's how the object-oriented programming, how object-oriented program works. That is, build objects, and then lets the objects interact to each other through sending messages. Okay, so that's a very different way, very different mechanism from the procedural languages. Okay, so that is more example about the interaction between objects. The objects will interact through sending messages. What about the class? Yeah, the class in object-oriented programming is also very important. It's a set of, that is a description of a set of objects that share the same attribute, operation, or relationship semantic. I just want to introduce you here. For example, here you have the account of Dubing, and you have account of another person like Mrs. Hulan or other bank customer. Each object will have different state. The state here, that means the value of the attribute. The value of attribute, for example, being in 2 million, in 2 line 1 million. That is the value of the set of value of or attribute of the object will make the state of that object. So the account Mr. Dubing will have a state, and the account Mrs. Sulan will have another state with the different values of the attribute. Okay. So that they are two different objects, and maybe we have millions of different objects in the real life. However, they share the same attribute and operation. So we generalize to the class. We call account class, something that we say a model objects, will have some attributes, the common attribute of all the account object in the real life. So all the account object in the real life, they have the name, the balance, maybe the account number, and some other attribute also. And they also share the same operation like deposit, withdraw, check balance, or maybe transfer money, or some other operation, some common operation of all the accounts in the real world. So the class is something like the model object or blueprint of the objects. Okay, so in the class we define the attribute, the common attribute of all the objects, and the common operation of the objects. Okay, so in conclusion, to saying about the difference between the structural programming language and programming and object-oriented programming, we can look at this equation. With the structural programming, we need to learn about the data structure and algorithm. And we build the data structure, and we build the data from the data structure, and we build the function from the algorithm to make the program, right? But in object-oriented programming, we need to build the objects and the methods to build the program. Okay? So the data structure and the algorithm is inside the object already. Okay? And the objects interact to each other through sending matrices to make the program. Okay? So that is the main point when we compare between structural and object-oriented programming. Next part, Java. So what is Java and why is Java in this course? Java is an object-oriented programming language, and it's developed by Sun Microsystem, and now Sun already bought by Oracle. So that's why when you want to download Java or some other material, some other resources, you need to go to the Oracle website because already bought by Oracle. And Java is invented by Green Team, and James Gosling is the leader of that team. It initially used for building the control processor application inside the electronic consumer devices like microwave, CD players, or washing machine, something like that. Yeah, that is the first intention when they invent Java. However, because of many advantages of Java, so that's why it expand to many other types of application and evolve to a very, very well-known object-oriented programming language. I mean, the huge community. And what is it? Can you guess? A cup of tea, right? Maybe any cup of anything, right? One thing that it is a cup of tea. Any other opinions? What is it? Can you guess? A cup of hot blood. Oh my God. Okay. A cup of coffee. Okay, so you can see a cup. It's very clearly, right? A cup. It's true that is a cup. But cup of what? So, in fact, that is a cup of coffee. Yeah, that's right. That is a cup of coffee. Why Java? The logo of Java is with the cup of coffee. So when you drink coffee, what is the first feeling? Is it sweet? Java is an Iceland It's famous for coffee. Okay, that's a good information. But I will give you more information. Okay, so first, Java. The name of Java is not Java. It's awk. You know what is awk mean? Awk. Okay, soy. Yeah. There are many awk trees in the software part of Sun microsystem at that time. So when the green team look through the windows and they see everything is awk, so that's why they named for the new programming language is awk. Many teams want to use Java, and they say, oh, awk is very difficult to pronounce and remember, so they want to change the new name. They visit Java Iceland. They try a cup of coffee, and they say, oh, it's very good coffee. And they ask, what is it? And that is a very well-known coffee in Java Iceland. And the name of that coffee also Java. So they thought, oh, why don't we use that name for the new programming language? When they try to taste the coffee, what is the first feeling when you drink coffee? Is it sweet? Is it sweet? Or
You mean bitter taste?
yeah, the taste? Bitter, right? You say bitter? Yeah, bittersweet. Bittersweet, I mean, from beginning it's bitter. And then you will find that it's sweet, right? So that is the same way they want to present Java. Java, firstly, when you learn it, you will find that it's bitter. Because it's not easy to learn Java. Java is something, it's not, for example, Python or some other language, maybe it's not difficult to learn, very quickly to learn and very quickly to write the program. But with Java, it's more difficult. It's like a very strict language. You need to follow the rules, and yeah, you need to. I mean, that's at the beginning. It's bitter when you learn Java. However, after the bitter, you will find the sweet. When you master Java, when you already learn it, and you will fall in love with it, like you addict the coffee. So that's why they use Java to name for the new programming language. Okay, Java has several editions. The standard one, you can use that edition to develop and deploy for Java applications on desktops and servers. Okay, and in this course you will use this edition, because that is like you use Java to demonstrate for the object-oriented programming. So you only need to use it for the application, desktop applications. So that's why we use this edition. Java also, in this edition, you have the JRE and JDK. JRE is runtime environment, and it will provide the environment for the Java programs to run. Okay, and JDK, that is development kit. The JDK include the JRE. Okay, but not only JRE. JDK also include other tools like compiler, debugger, and some other tools for you to develop the applications. Okay. Java Enterprise Edition. That is another, the second edition of Java, that when you want to develop some more complex applications. Some more complex, like distributed computing, or web services, or web applications, or enterprise applications, etc. So when you want to develop such thing, you will use that edition. It's like an extension of Java standard edition. Java is extend. Yeah. Also, Java have another edition for some application running on embedded and mobile application in the internet IoT, like microcontrollers or sensor gateways, mobile phone, PDA, printers, or some consumer devices like TV box, CD player, yeah, washing machine, something like that. So there is another micro edition, so that you can use this edition to develop such applications. Okay, so I say again that in this course we will use this edition, that is a standard edition. But maybe in the future you may use some other edition, maybe in another course, or maybe when you work in the company, yeah. So maybe you will use such other edition. Okay, so Java is not only the programming language, but also the platform you can see here. When we say about the platform, we have the host platform like the OS, for example, and you write the Java program on the top. But you need the Java virtual machine. Java virtual machine is inside the Java runtime environment. It's like a virtual machine so that the Java program can run on the Java virtual machine. And when you write the Java program, you need to use some library. So that is Java API. The Java program that you write will use the library, Java library, through the Java API, and then you will have a Java program already compiled, and the Java program already compiled when running Java virtual machine with runs in host platform. Okay, so as I already introduced you, that the first intention of Java is used for embedded software, right? Like electronic consumer device. Because the compiling model of Java is very different from other languages, so that they can port from this device to another device. It's not like the C or the assembly. It will vary very depends on the platform or hardware. When you write the source code in assembly, you need to just, for this hardware, you can only run in that hardware, right? So firstly, that is the classical compiling model. So from the source code, it will compile to the binary code. The binary code is the machine code for each hardware. For example, if I want to run the program for the IBM machine, I need the compiler for the IBM machine. If I want to compile in Mac OS, I need to have the compiler for the Mac OS. Okay. So when I compile the source code to the binary code, that is the machine code of each type of hardware, I can run that binary code in only that hardware. I cannot use this binary code to run, for example, binary code of IBM to run in Macedon, or from Macedon to Spark, for example. So it's like platform dependent. So the compiler also belongs to each platform. However, for Java, we can say that it's platform independent because we can compile the source code to the bytecode. Bytecode is not binary code. The binary code is like the machine code of each hardware. However, bytecode is a new terminology of Java. So there are two steps in compiling mode of Java. First, compile to the bytecode, then interpret to the machine code of each platform. So do you know the difference between compile and interpret? Anybody know? I think you know. Compile and interpret. What is different? Interpreting, that means run line by line. Okay. What about compiling? Compile, run the whole program. Thank you. The idea is okay, but not only run, because interpret and compile, that means translate, right? Okay, so you have the compiler and interpreter. Not for only software, but you will, like in the real life, when you need to translate from this language to another language, right? So if that is compiler, that means after the source language already deliver the whole paragraph, the whole document, and then the translator, the compiler, will compile and read the translated document in the whole document. Okay. What about the interpreter? So the source language will be deliver one sentence, and the translator will also read the translated sentence immediately after the one sentence by sentence. Okay. The same for the software, as I say here. Interpret, I mean line by line. Line here, that means the statement by statement. And compiling is the whole program. So, but it's translate, it's not run, okay? Because that is a compile and interpret. Compile here, that means from the source code language, that is a high level language, to the bytecode language, from this language to another language. Okay, that is compile the whole program at once. Okay, if there are some errors, all errors of the whole program will be reported. So you have a list of the errors of the whole program after this compiling process. Okay, but interpret, that means it will interpret each statement by statement. If there is an error, it will report that error and stop. It will not interpret the next statement. So in the interpret, if there is an error, it will stop there, and the rest, the remaining statement, will not be interpreted. Understand? So statement by statement, statement by statement. And after interpret, it will run. Okay, so that's me here. So okay, that is the model of Java, and why it's called the platform independent. Because this bytecode, where after you compile to the bytecode, you can bring this bytecode to run in any platform, any hardware. Suppose that all the hardware installs your JVM or Java runtime environment. That is obligation, because if you want to run the Java application, you need to provide the runtime environment for that platform, for that hardware. Okay. So in the JRE, there is Java virtual machine. In Java virtual machine, there is a interpreter. that will interpret from the bytecode to the machine code of the hardware, the corresponding hardware. Okay. So what the program need to do? Just need to write code one time, compile one time, and bring the bytecode to run everywhere in any platform. So that's why Java has a slogan that is write once, run everywhere. So you just write one time, write and compile one time, and you can bring the bytecode to run everywhere with the support of the JVM. Okay, so just come back to the initial intention of Java when they invent this programming language for the controller of the consumer devices, because they just need to write one time and compile one time and can run any platform because of the device, the consumer device like washing machine or CD player, etc. It can have different, maybe different hardware structure, hardware architecture. So they don't want to be depends on the hardware structure. That's why they invent Java so that they can have platform independent. Okay. Okay, so just introduce you about the compiling model, and when you develop Java applications, you will need to edit, the editor or IDE to make a source code with the .java, and through the Java compiler with that command is Java C, Java compiler. You will get the bytecode, that is a bytecode. The bytecode, that is a platform independent. The bytecode is .class. And you can bring the bytecode to run everywhere with the support of JVM. Okay. So JVM is the heart of Java language. Yeah. And it has the interpreter just in time. Translate from the bytecode to machine code for the entire hardware. Okay. And Java has many advantages. Powerful programming with a huge community, full with many, because it's a huge community. So the API, the library is very huge for you. So it's very convenient and very fast for you to develop a Java program. It's easy to learn, similar to C and C++. If you already know C, the syntax Java is very similar. Platform is independent, you know it, and support the, yeah, it's not only the standard edition, also I think that you to develop the application in network environment like distributed computing or web service or some other thing. So that is some feature. That is more thing about this feature. I think it's just more detailed information. You can look at it. Yeah, Java have a multi-threaded mechanism, very strong. You can develop the application applet, web, mobile, and some other like not only Java can use for backend, very stable and very efficient. I mean, performance is very good. I already have some tests between Java and Python when you write for backend, for example. For some tasks that require a long time for processing, Java will be faster than Python about very surprised for me. Exactly about 3 to 5 times. Very surprised for me. But it's true because when we port from Java to Python and test very strictly, I mean, to ensure that the similar algorithm. However, Java is faster than Python about 3 to 5 times. And just provide you one thing about applet. Maybe you have some question about applet because it appears here in some other else in the slide. So applet is, I can say applet is something like the historical Java. Applet is very famous, very well known in the past. It's a GUI application. You know GUI? Graphical User Interface application running on browser in the client side. Why it's well known? Because about 20 years ago, about 2000, when I was a student. Applet is very well known because at that time the web application is very poor interaction to the user. You don't have any something like front end or back end. No, you don't have front end at that time. And the web client is very depends wholly on the server. And when you use the web application, it's very terrible user experience. Because whenever I click a button, I need to wait a long time to get a response from the server. Because at that time, only like synchronous mechanism between the client and server allowed. That means the client need to wait for the server to process any request and get the response. So if the network is not good, if the request need to wait for the server because so many requests at one time, so the client need to wait. So when the client click the button in the client side, it need to wait 1 second, 2 seconds, 3 seconds, and sometimes timeout. Very poor experience, and we don't have so much way to develop the interaction between the client with the user and the UI. So at that time, the application, desktop application is very popular. It's much more popular than the web application. However, when applet appear, it can embed it in the web browser. So when we develop a web application, we can develop applet and embed it in the web browser. And applet is like a desktop application. So we can have many interaction between the user and the application. So that's why the applet bring a new face or a new user experience for the web application. So that's why at that time applet is very famous, very popular, very well known. However, that is a script can run in the client side, so there are many problems with the security. So after that, the applet, maybe several, I think about 5 or 7 years, applet is very well known and very common, but there are many problems with the security. So with the development of web application, so applet is not used anymore. With some very old web application, maybe they still use applet. Yeah. But with the default configuration of the web browser, it doesn't allow for applet to be run in the web browser. You need to enable that. Okay, so that is a historic thing. But I just want to say, applet is one of the very important things that help Java to be well known in the world. One important thing. Okay, so I think it's enough for Java, and just give you some example. The first example is of the hello world, very easy one, that you want to print out to console like this. That is the way you can do system.out.println, and you should put it in the main method, and you need to strictly use the signature of the main method, like public state void main, because the main will be called by JVM, Java Virtual Machine. So you need to declare exactly the same way like that, so that the JVM can call. And any method in Java need to put in a class. So please understand that is the obligation, that is a rule. So you need to have a class. Okay, so the first example is like introduce you what is how to run Java. But the second one, of this slide, you will be introduced and practice in the hands-on lab. Okay. The second example with the GUI, graphical user interface, that you can show messages like this with the library from the Java, that is the Java X plus Wing. So you can show message dialogs by calling the show message dialog method. Okay. Or you can ask the user to input a name using the show input dialog, and the value is stored in this variable. Then you will show that variable to the user. That's very simple example for some then very first example in Java. You will have much more example and exercises in the labs section. Okay. Okay, I think it's enough for this lecture today.
So Miss Chang, if I'm correct, then Java compiled the Java file into object files, right? And then it used the object file to read and interpret it for us, and then it can be run as a program.
Okay, good for your question. So in fact, it's not object file. Now the object file is from the C, the classical compiling model. So when you translate, you compile from the source code to the object file, that is a binary. So this they are the object file. But in Java, it's not object file, it's called bytecode. And object file depends on the platform. So when you compile the source code to object file, that means you need to know that the object file is for which platform or which hardware. So object file depends on the hardware, but the bytecode is not depends on the hardware. Okay, it's the same.
Okay, thank you.
As just said more, this bytecode will be interpreted to the machine code, so using the interpreter in the JVM. That's it. Any other questions? I cannot see any question in the text chat. Okay, I have one. Does JVM depend on the hardware or it used for override? Oh, good question. What do you think? The JVM is in fact, when you want to have JVM, you need to install the JRE. And when you install the JRE, it depends on the platform for sure. It means that when you want to install the JRE for IBM, there is a JVM, JRE for IBM, JRE for Spark, JRE for Macintosh, differently. But as I know, when you normally when you go to the website, it will know exactly what is the OS of your system and recommend you to install that version. But you can choose. So my answer is different. They are different. The JRE will be different from IBM's platform manager and other hardware or other platforms. The Java will support all the platforms, so it's not a problem. Because the JVM will interpret from the bytecode to the machine code, so they need to understand the architecture of the machine code, yeah, to interpret. So that's why we have specific interpreter for each platform. Okay, any other questions? Seems no. Thank you and see you again. Bye bye.